on YouTube? Jordan here, aka Cheat Buddy. Welcome back to another video. This is part 5. We're talking about entities, finding entities in your game. In the last video, we talked about um, we're talking about how EDI is the base class. We found that it did have a virtual function table when we dissect the data structure, and so now that we found that EDI is the base class, we can now trace from this function here that access EDI, or the pointer, I should say, which again, this is pointing to our coordinate structure. And you can see here that you can see here the instruction says it's moving EDI plus D4, EDI plus the offset D4 into XMMO, and you can see the values here in XMMO, and you can see that 3 there, and that 3 is also here. This is for my float. Now keep in mind, since the last video, it's a completely new day. It's 11 o'clock today, and the address is not the same anymore, or not the same as the one in my last video because I had to start the game over. But essentially, everything is set up. Everything is still set up the same. Nothing has really changed, and now we're just going to keep going through the process of reversing this structure. So to go ahead and do that, we're going to do a break and trace on this instruction right here. Where essentially we just want to find, so we know that EDI plus D4 is pointing to our coordinate structure, and we know that EDI is a class. So you could view EDI as a child class. So let's go back to our lecture again. So you see here, again, back with our entity, how it inherits from big brain, and then big brain inherits from little brain. Alright, now when we go down here, Prince of Oblivion, that's going to be the base class, or you could also consider it the parent class. And then this is the base address for where big brain would be in memory. You would have that class there, and this would be big brain would be considered a child class. It would be a child of this parent object here for Prince of Oblivion, and so on and so forth. You could see the same. It would be the same with little brain. Little brain would be the child of big brain, if that makes sense. So big brain is the parent to little brain. It's just how the hierarchy works. You know, it just kind of goes up. So in the same sense, we go ahead and minimize this now, and we go back to our function. So we know that EDI is a class, so we know that EDI is a child class, and when we add the offset D4, it points to our coordinates, okay? And then that gets moved into the register XMM0, all right? So now now that we have that together, real quick, I want to discuss some things before we start diving in. Again, I'm using this OpenRCE site to explain classes to you. And so real quick, I just want to explain calling conventions. We're going to talk about this one here. So remember earlier I was talking about how in the Visual C++ compiler for Microsoft, whenever it creates classes, it puts the functions for those classes, it puts them in a virtual function table. All right, well, there's another thing that it does. In C++, there's a thing called this, or this call, and whenever you set up any function or any method that you set up in your class, when you're using the Microsoft Visual C++ compiler, by default, it's going to use what's called a this call. And how a this call works is you consider like a variable that's always pointing to your structure. So this is basically like a keyword, and it always points towards your structure. So you could say, see, I got entity Prince of Oblivion. Now, instead of saying, Prince of Oblivion, if I wanted to access, so I did an example here already in what's called the constructor. So a constructor is basically something that's called whenever your class is created. So your class is created, and then you could have your constructor, initialize values and stuff like that. And so in my case, I'm using the this. Like I said, this is just pseudocode here, so don't judge me. Um, just trying to show an example. So you can see this dot x equals 0. What this variable is basically saying, it's saying to access this Prince of Oblivion here and find the x and set its value to 0. And then it's saying to find the y coordinate, which, that's your gravity, it's your up and down, and it's setting that to 50. So, it's going to tell Prince, to jump 50, 50 feet in the air, or, what have you, whatever measurement, um, depending on, what game we're using. In my game, we're just going to say feet. So 50 feet in the air, for example. And then I just set the z to 0. So that's kind of how that works. So the this always points to the object that was created. And then whenever we're talking about this in machine code, it's always referenced by the ECX variable. So in a lot of these functions, you're going to hear me talking about it. And, I'm going to say the ECX that's used to reference, um, the class basically, or the object that derived from that class. So we're going to go ahead. What we're trying to do now, we're trying to find EDI because we know that EDI is a class and it's a child class. So we're trying to find all the parents of EDI until we get to like the very, very top so that we could find a static address and we could always point to different areas in memory. So to do that, we're going to go ahead and do a break and trace. You can leave the default 1000. You want to go ahead and click on Save Stack Snapshots. It does eat up your system memory, but I think it's pretty useful to be able to see the stack in real time when you're reversing because there's a lot of important information in there, and we'll probably use it. So the other thing that you want to do is go to step over instead of single step. That's going to basically prevent Cheat Engine from like going inside irrelevant functions that we don't need. So yeah, we don't really need it to step into any functions since we're just kind of backtracing here. And if we ever do need to go into a function, we could do it manually. So I'm just going to go ahead and click OK and let it do its thing. All right, boom, it did its thing, and now it's done. Um, so it stopped at this function here. I notice, see the string here? This is basically this. We're inside the task scheduler. I know this by experience. We're not going to talk about this in this video, but this is basically what automates all the tasks in your game, the rendering and all that stuff. This entire function kind of handles all that. And yeah, so that's what that's for. So go ahead and click on run. And now we're going to go back to the tracer function. All right, so we want to go ahead and right click and click on expand all. And we're going to stretch this out. Let me do this real quick. I'm going to go ahead and add this to the code list if I haven't already, so that we could come back to it later, and then we'll just go ahead and close it here. Okay. We'll just open the memory browser again. All right. So like I said, we want to find the parent of EDI. EDI is a class. We want to find the parent of it. So we're just going to kind of go up through the code, and we're going to see what is moving. Which one of these instructions is moving something into EDI. And right off the bat, I see one right here. Remember, guys, whenever you're dealing with assembly Intel syntax, you read from right to left. On the right side is always going to be the source, and on the left side is always going to be the destination. So you could think of this, I don't know, easy example, you could think of this like, I don't know, think of the right side as like, some kind of delivery service, and, the EDI, or not the EDI, the destination is like that's where your package is going. So, yeah, we see that EBX plus 5C is what's going into EDI. Now, this is a pointer. We're going to go ahead and add that to the code list. And so, because EBX is here, we're going to want to find now we're going to check in a second to see what EBX is, to check to see whether or not it's a class. Um, See its offset here, so it probably is a class. Whenever you see an offset, normally like this size, I have a norm just based off experience. I could say that it's probably a class, but I'm just gonna leave a note for myself here, and I'm gonna say we need to find the source of EBX. So we need to find out. We know what's being moved into EDI now, and so we know that the parent of EDI is probably EBX. That's if EBX is a class, okay? And so if EBX is a class, that means that we found the parent to EDI, and now we need to find the parent of EBX, okay? So let's go ahead and hit OK, and now you see everything is all neat and orderly in our advanced options window, or the code list. So now we need to see where EBX is coming from. So you go up some more and you see that EBX is coming from the um, the ECX variable, which, remember, like I said earlier, ECX is this pointer, which that's normally, always referencing an object, okay, or a class. Oops, didn't mean to open that. Let's continue. So now we know that EBX gets its value from ECX, and so now we need to find the source of ECX. All right, and give me a second here, guys. I want to find something to explain to you. Okay, so I found what I was looking for. It was on the OpenRC page. So it says here that all class methods in Microsoft Visual C++ by default uses the this call convention, which we just talked about that. That's this call, and we found it. It uses the this pointer, and the objects are always in the ECX variable. Okay, classes are always in the ECX variable. All right, and so the saying is passed as a hidden parameter in the ECX register. We know that. In the method body, the compiler usually tucks it away. In the method body, this is basically the function of the code. So this would be the function. This is our function. It starts with a push. So tucks it away immediately, and it says the compiler usually tucks it away immediately in some other register. All right. Usually it's ESI or EDI, or it could be on the stack or some kind of variable. Okay, but we could kind of see that here. So we know that ECX is that this pointer, and immediately when it jumps in this function, immediately you see it takes ECX and it put it in EBX. It's putting it in some other variable to kind of store it away, in some other register to store it away. So just wanted to go over that real quick. Um, so let's continue where we left off. We need to find the source of ECX. We're at the end of our function here. We can't go up anymore to see. These int3s kind of just don't really know how to describe them. I think they're just like pattern. I think every compiler does it differently. In Microsoft Visual C++, whenever there's not any code there, I think it just puts the instruction int3. But I'm not too sure on that, but yeah. Anyways, so we got everything that we need from this function here that had this instruction that points to our coordinates. So we don't need this function anymore. So we're gonna hit this minimize tab, and now we're gonna go to the function. Um, this is gonna allow us to backtrace. This function here is gonna backtrace into the function that called it. So uh, this is the return address from that function that we just minimized, and so this is the instruction that's executed after that function is called. So this is the function that we just came out of right here. If I hit follow, you can kind of see the code again. You see? All right. So we're outside of that code, and we're inside what called the function now. So this is the caller, and we know that we need to be looking for ECX. Okay. So we're gonna kind of go up, and we're gonna look for ECX. Okay. Right off the bat, we see that ECX comes from EBP minus 40. If you guys haven't seen my last video, in the stack, we in the stack, how the stack works, whenever EBP is used to reference uh, arguments or parameters, this is the stuff that you pass to your functions, strings, numbers, whatever, what have you. Whenever you call your functions, you know what you pass to them. your parameters, they're always going to be at EBP plus. So it's going to just keep going up, and all your local variables is going to go downward. So it's going to be minus, okay? So in our case, EBP minus 40, we know it's not a plus. So that means that it is a local variable within this function, okay? So ECX is getting its value from some local variable in this function, and we see that it does it here again. Now we just need to find the source of that local variable EBP minus 40. All right, so I'm gonna put here find source. This is very important that you track all of this stuff. You guys are gonna see why when at the very end when I make the pointer, the multi-level pointer. You're gonna figure out why I kept record of all of this stuff here. So we're looking for EBP minus 40. Keep on going up, keep on going up, keep on going up. Still nothing so far. We did see EBP minus 40 again here, but it's just moving it into ECX. It's not it's the source, it's not the destination. So we're looking for it on the left side. That's EBP minus 30 there. And it's a really big function, guys. Just keep scrolling up. Here we are. And we see that ESI is what gets moved into that local variable. So now we need to find the source of ESI. Alright. So we found that ESI get its value right above it. You see that it gets its value from EAX. So now we need to find the source, EAX. See what I'm saying? I'm using the Jesus, if I could word my words right, to the left of the offset. I'm basically using the instruction, and later on we're gonna check, see if all of these are classes. So I'm gonna add that to the code list. And now we need to find the source of EAX. All right. So let's go up. You see a call being made here. Evidently, we don't see anything getting moved. This test instruction is just a compare. We're trying to look for a move, something that's moving a value into EAX, but we don't see it. So it's probably going to be in one of the function calls. Okay. And so I'm going to check this closest call here. I'm going to go ahead and follow it. And matter of fact, I'm just going to set a breakpoint on the function. All right. And just going to go ahead and go to debug and step. And then instead of doing debug step all the time, I'm just going to be pressing F7. I'm just going to kind of see, just kind of track the flow of the code. All right. And so as I'm pressing F7, I see that it takes me right here to move ECX plus 2D8 into EAX. And see, we're trying to find the source of EAX. So that's exactly what we need. All right. So now we're just going to go through the function, and now we exited the function. And boom. Now we got what we need, man. We got what we need. So now we need to find the source of ECX, okay? So put that like that. All right. Source of ECX. Now we see here that ECX is now getting this value from EAX. All right. So we're gonna need to find the source of EAX again. All right. No biggie. We're gonna take care of that. Same process. You toggle a breakpoint. You follow. And you see where it's get its value from. And see, it says here that EAX gets its value from ECX plus 4. So you add that to the code list, and that tells you that you need to find ECX again. And so let's go ahead and step and exit that function and just hit run. All right, let's take a break. Hold on. I forgot to remove my breakpoints. Toggle breakpoint. Oh shit, bro. I done fucked up the code. Hold on, YouTube. Hold on. My application is gonna crash. I gotta pause the video. Okay, cool. It didn't crash on me, so we good. I was gonna be kind of upset if it did. Anyways, now we gotta find the source of ECX. Okay, finding the source of ECX. And we could see here we're approaching the beginning of the function, and we don't see anything that's moving into EAX. So that means that we need a backtrace into the function. I keep doing that. That means, oh my gosh, bro, I'm gonna move this like over here. All right, there we go. So now we're done with this function here. We can now minimize it, and now we're gonna look at the function that called it. I don't even know if, did I do that right? Um, uh, don't think I minimized. I think this is that same function that I was in. Hold up. Let me scroll up to check. Um, this is probably that long function that I was just in. But you know, I gotta be sure, man. You gotta be sure. Yeah, see, so we just had our breakpoint set right here. We just came out of that. So yeah, I didn't minimize it. It must have been some kind of mistake. I double clicked or something. All right, there we go. Now, now we found what called it. Um, Again, we need to find the source of ECX. After we return, this call right here is what called the function that we just came out of. This is the return address. So we're tracing, we're going backwards, so we need to find ECX. We find that ECX is getting its value from EDI. Now we need to find the source of EDI. Oh, I forgot. I needed to tell you guys something beforehand. Um, what was it going to be? Oh, yeah. So in more complex games, in really big games, whenever I'm doing pointers, I try to keep my pointers at least like, um, they should at least be having like, about between 6 and 8 offsets. Um, no less than 6 for more complex games. Some games, multi-level pointers, you only need like 3, 4. Other games, they need more. More complex games, they need more. So for me, I did try 4 on this game earlier, and it did not work out too good when I did a pointer scan. So I went ahead with 8, and that gave me some pretty good results. So right now, we're manually making our pointer. And so I'm tracing. How do I know that when I come to a stopping point is when I know that I have enough offsets. So remember what offsets are. They're anything that happens after this plus, okay? Anything that happens after the plus. And whenever it comes to looking for pointers, EBP and ESP, you don't worry about those because that's temporary memory that's on the stack. So that is just temporary. You don't really worry about that. That's just used for storing your local variables. So whenever it comes to offsets and stuff, you don't worry about these. But you see here the EDI plus D4, all the stuff that's our class basically. Um, the D4 here, this would be an offset, so that's one. 5C, that's another offset, that's two. Again, we're not worrying about EBP or ESP. A8, that's 3, and 2D8, that's 4. ECX plus 4, that's 5. So we have 5 offsets right now, and we're trying to. I'm gonna try to get around 7, 8, uh, yeah, some around there. So I'm gonna come to a stopping point, and we're gonna check to see if we have our static. So once I get to that amount of offsets, of course. So we're just gonna keep tracing. So we need to find the source of EDI, and we're gonna go up and try to find what is, what in the heck is, um, putting something to EDI. Let me go back and do this because I'm a little bit confused. Um, actually, what am I doing, bro? I need to be finding the source of ECX, okay? I just realized something. This is the return address. I'm supposed to be moving upwards, not downwards, because we're trying to see everything that happens after or before the function, not after the function, okay? Because it's called back. That's why it's called backtracing. We're trying to see what happens beforehand. That's why we're going up instead of down. So let's us go back to here, and we are trying to find the source of ECX. My mouse is like double clicking really rapidly, and it's making me like mess up. I don't know why it's doing that. But anyways, we're going up. We see here EDI gets moved into ECX. We did this one before. This is the right one that we need to do. Okay. Again, EDI moved into ECX. EDI moved into EAX. And just keep going up and see. This says move ESI into EDX. That's not it. That's not it. That's not it. Let me just rename this real quick so that we're not confused. We're trying to find the source of EDI. And it says here, EDI get its value from EBP plus 8. So, I did not fuck, dude. Oh, man. Hold on, guys. Alright, my bad, guys. I done goofed and accidentally crashed the game, but it's all good. We're good now. So, this is where we left off. We're trying to find the source of EBP plus 8 over the first param slash argument. Reason why I said the first param slash argument, param is short for parameter. EBP plus 8 in our functions, remember when we go back to the calling conventions in assembly, EBP plus 8 is the first parameter. That's all your arguments. That's all the stuff that you pass to the function. And so it's saying that EDI, it's getting its value from that first argument or first parameter of this function here. Okay, so um, when we look for that, we need to we need to go ahead and backtrace, because that is it's gonna be pushing it onto the stack before it calls this function, because the push instruction, that's how assembly passes arguments to function parameters. It uses the push instruction, and then it goes into uh, that location, that EBP plus 8 here. Alright, so we're going to go ahead and minimize that, and let's get the return address, and then we go up, and so we see push EAX. Okay, real quick, I'm just going to set a comment so that we're not confused. So this EAX is going to be the EBP plus 8. This is the first argument. The last push instruction before a call is always going to be the first argument. Okay, so now we need to find the source of EAX, because we know that it's the first argument. I'm lost. Okay, I'm good now. Now we find the source of EAX. There we are. It's right there in front of our face. Find source of ESI. Just keep going up. 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 Let me sit up, man. So, like I said, like my voice, my voice pitch changes whenever I'm laying down. So we got to find the source of ESI. Here it is. The this pointer is getting passed into ESI. And hold on, guys, I need to check something again. Obviously, we're at the we're at the beginning of the function. So now that we need to trace and find the function that called that function. So minimize again, and boom. All right. So we need to find the source of ECX. This call right here is the function that we just came out of. The pop EBP is the return address. We want to work our way up. We see that EAX plus 14 is being moved into ECX. We see that now we need to get the source. Bro, you know I gotta name these. I can't be slacking because they're real important, man. Find source of ECX. It be, you be thinking it's so simple, but you could get really confused real quick whenever you reverse engineer. So I'll keep track of everything, bro. Find the source of EAX. All right, that's what we're doing. Now we found the source of EAX. All right. Now we need to find the source of EBP plus 8. That's that first argument. Remember, that's that first parameter again that we talked about. So whatever is being pushed before this function is called, that's going to be what EBP plus 8 is equal to. All right. Hopefully that makes sense. Minimize again. Add ESP plus 8 or comma 8. Here we are. Says here, push EAX. Says it right here, push EAX. Let's add that. Let's say this is EBP plus 8. Find source of EAX. Set a comment right here. Let me know. This is EBP plus 8. Alright, let's go up. Saying that EBP plus 8, it's saying that EAX get its value. Sorry, I got a little cold. It's saying that EAX get its value from EBP minus 14. Add that to the stack too. Now we need to find the source of EBP minus 14. Alright, find source of EBP minus 14. Boom. That's so whenever you see a lead instruction, it means that it's trying to pass. Typically, whenever you see, again, this is something that I know from experience, and you guys could really only know what I know from how could I put it? From my experience, I could teach y'all this so y'all could save yourself some time because I already went through the trial and error of trying to figure this stuff out. Okay, so you see right here, it says move EBP minus 14, 0. But then it says here that it's loading the LEA or LEA stands for load effective address. It's basically loading the actual, instead of taking the data that's inside, it's taking the literal address. So whatever the address that's in EBP, it's going to subtract that from 14, and rather than taking the value at that location and putting it in EAX, it's going to take the actual address and then put it into EAX. Okay, and whenever you see something like this before a function is called, or you see like a LEA and then you see that same register that the LEA was performed on, it's pushing that before it calls a function, that means you need to scope that function out because that means that the value might be set in that function. That means that it's probably passing, as you know, EBP minus, whenever you see a minus, that's a local variable. So it's most likely passing this local variable to this function here, and then this inside this function, it's going to set that local variable. So before we even keep going up to see if EBP minus 14 is anything else, since this one is the closest, if this function is actually modifying it and it's right here beside right before our call, then that means that this is where EBP minus 14 get its value. So let's go ahead and go toggle breakpoint. You guys already know. All right, that F7, I'm just going to use the hotkey. So we know that EBP plus 8 is that local variable, EBP minus 14, because how do we know that? How do we know that, you ask? Well, thank you for asking. I'm going to show you right now. Now, this give me another opportunity to teach you guys something else. You see this says EBP plus 4. Let's go back to those calling conventions. It doesn't necessarily say it here, but this you see it is 16, 12, 8. 4 is always going to, EBP plus 4 is always going to be the return address, even though it doesn't explicitly state it here. So we're going to go to the return address real quick, which is the function that we were just in. All right. So you're asking me, how do I know that EBP plus 8 is EBP minus 14? All right, because we loaded that local variable into EAX, and then we push EAX in the stack, making it the first argument. So whenever we reference EBP plus 8, that's that first parameter or argument. That's essentially that local variable, EBP minus 14. And it's saying that we're going to put that into EDI. All right. So that local variable is now an EDI. So that means that we're going to be looking for something that's moving. Let's set a comment. I'm going to just put equals to EDI. All right. They're equivalent. All right. So that means whenever to set EBP minus 14, you'll be finding whatever is setting or moving a value into EDI. Okay, so let's keep stepping through the code, bro. Let's keep stepping through the code. And it says here, ECX is being moved into EDI. Okay, so remember, read from right to left. Source on the right side, destination on the left side. All right, so boom. So now that we know what's being passed into that local variable, we need to find the source of ECX, because we know that ECX is being moved in there. All right. So where does ECX get its value? Let's see. It's saying that ECX got its value from EAX. Well, there's also a jump right here, so we might need a check to be sure. So what I'm gonna do, I'm gonna view breakpoint list, and then I'm gonna hit run so that we can start from the top, and we could see again where